All right, guys, here we go. So this is the factoring review. When you're factoring radicals like this, you can do it a couple different ways. I personally like to break it down into the biggest perfect square I can find that will factor into it. Like in this case, it would be the square root of 4, which then becomes 2, and the 7 just stays as the square root of 7. So you can do it like that. Or some people like to do the pairs and squares. So you've got your number 28. You pick your factors. In this case, again, we'd use 7 and we'd use 4, or 4 and 7. And then 4 would break down to 2 and 2. And so here's your prime factor tree, basically. All these are prime factors. If you have a pair that are the same, you circle them. And then the one without a pair, you put a square around, pairs and squares. So the square is what stays under the radical, and the pair is what you put in front, like this. So it's 2 square root of 7. Okay? If we did that over here, let me pull up here a bit. See if I can. There, that might be better. All right, so here, for instance, we could do 32 and 2. Okay? Which... no, it's 34 and 2. I'm sorry. Ooh, that's terrible. What the... All right, let's try that again. So this would be 34 and 2. And then 34 can be broke down to 17 and 2. So again, we have a pair there, set of 2s. And then we have a 17 that's a prime number. So in this case, it would be 2 square root of 17. Over here, we have square root of 9 over 18, which I would reduce down to square root of 1/2, which becomes the square root of 1 over the square root of 2. Square root of 1 is 1 over square root of 2. Now to get the 2 from underneath the radical, we multiply by the square root of 2, but we have to do it to the top as well. So that becomes 1 times square root of 2 is square root of 2. Square root of 2 times the square root of 2 becomes the square root of 4, and we all know that the square root of 4 is 2. So there's your answer. Okay, on this one, we take 5 times 10 is the square root of 50. And 50 can break down into the square root of 25 and the square root of 2. Square root of 25 is 5, and square root of 2 stays as it is square root of 2. Okay, now if you did the pairs and squares here, I guess I could do that over here. 50, and we go 25 and 2, and this becomes 5 and 5. So this is a pair, this is a square. So again, 5 square root of 2. Okay, same thing. All right, over here, we have square root of 4a squared. Well, we can rewrite this as the square root of 4 times the square root of a squared. So square root of 4 we know is 2, and the square root of a squared is basically, you cancel those out. The radical and the square cancel each other out, and you're left with just 2a. Okay? We're going to skip this one. This is a ridiculous question, so we're just going to leave that. Okay? Here, notice we have a 3 in front of this 3x to the 4th, but we don't have any numbers over here. Okay? Which means we have one of them, right? We have one of these. Okay, over here we have 3 of these, but we only have one of these. So when this happens, you take the numbers that are outside the radical and multiply them together. Okay, so 1 times 3 is 3. And then you take what's under the radical and multiply them together. So 3 times 3 is square root of 9. And then x to the 2nd times x to the 4th is x to the 6th, because we add exponents. So, again, that can be rewritten as 3, there's our 3, and then the square root of 9 times the square root of x to the 6th. Okay? Oops, sorry. Like that. And we know that the square root of 9 is 3, and the square root of 6. If you remember back when we were doing exponential or exponents, we said that like if you have x, the square root of x, that's the same as x to the 1/2, because this little guy is a 2 out here and there's a 1 there, so x to the 1/2. that means, if that's true, that this is x to the 6 over 2. Well, 6 over 2 is 3. So the square root of x to the 6th is x to the 3rd. Okay? You basically just divide it by 2. Okay? All right. So then 3 times 3 is 9, x to the 3rd. There you go. All right. Over here. Ooh, sorry. The square root of 4 is 2. And then here we have 3 minus the square root of 5. To rationalize the denominator here, to get the radical out, we're going to multiply by what's called the conjugate, which is that same thing here, except we change that to a positive. And if it was positive, we change it to a negative. Okay? But again, if we do it on the bottom, we have to do it to the top. So 3 plus the square root of 5. So when we multiply the 2 times the 3 and the 2 times the 5, square root of 5, 2 times 3 is 6. And then the 2 times the square root of 5 would be 2 square root of 5. Okay, on top. On the bottom, we have 3 times 3 is 9. And then the square root of the negative square root of 5 times the positive square root of 5 gives you a negative square root of 25. And the square root of 25 is just 5. There is no middle term in here. Normally when you multiply by binomials like this, you have to take the first times the first, the last times the last, and then you take the middle and the outers and add them together to get that middle term. But when it's the exact same thing, just a positive or a plus and a minus, then it eliminates that middle term, which is what we wanted. Okay, so now we have 6 plus 2 square root of 5 on top and 4 on the bottom. If you look at all three of these, the 6, the 2, and the 4, those are all multiples of 2. So we can take factor of 2 out of each one of those numbers. And so if we do that, sorry, all over the place here. If we do that and take 2 out of all these, we'd have 3 plus the square root of 5 plus the square root of 5 over 2. Okay? So I divided the 6 by 2 and got 3. Divided the 2 square root of 5 by 2 and got square root of 5. And the 4 divided by 2 is 2. So 3 plus square root of 5 over 2. All right. 100 x to the 3rd y. We can rewrite that as, sorry, again, all over the place. Trying to do this without a stand. All right, so the square root of 100 times the square root of x squared times the square root of xy. Now, the reason I pulled that x squared out, because I know it says x to the 3rd, but if you have x squared here and x1 here, that's x squared total. The reason I pulled it out is because if I put this in exponential form, it would be x to the 2 over 2, which is just x. Okay? So, square root of 100 is 10 times x squared, the square root of x squared is just x. And then the square root of xy just has to stay as the square root of xy. That can't be reduced any further. Okay? So, on the outside we have 10x, and then under the radical we have xy. Oh, my one got, there we go. Okay? Over here, we're going to do some more conjugate work. Okay, we're going to multiply this by 5 minus the square root of 5. And if we do that to the bottom, we have to do it to the top. So 5 minus the square root of 5. Okay? So we take 5 times, the square root of 5 times 5, and we get 5 square root of 5. And then square root of 5 times a negative square root of 5 is going to be negative square root of 25. But the square root of 25 is 5. Okay? And here we take 5 times 5 and we get 25. And the square root of 5 times negative square root of 25, again, same thing here, gives us minus 5. All right? So, square root of 5 minus 5 on top, and 20 on the bottom. So again, just like this one up here, this was all multiples of 2. These are all multiples of 5. So I could divide this by 5, divide this by 5, and divide this by 5. So when I do that, 5 square root of 5 divided by 5 cancels the 5's out, right? Because we'd have 5 square root of 5 over 5. It's going to cancel those out and just have that square root of 5 left. Sorry. Okay, so we have square root of 5. And then 5 over 5 is 1. It's a negative. And then 20 divided by 5 is 4. There's your answer. All right, on this part, it says factor each polynomial. So they're wanting you to break this down into the two things that multiplied together give you this, okay? They're not wanting you to find an answer. Notice there's no equal sign, all right? They're just wanting to say, what two binomials can I factor down and get this answer? So for example, I make my two sets of parentheses here, okay? And I know, remember this first part, or this first place here and this place here multiplied together are going to give us p squared. So what times what gives us p squared? Well, it's p times p, right? And this back piece over here, this back number, is going to multiply together to give me 64. The thing is when I multiply, or when I add these together, they have to add, these two multiples have to add together to give me negative 16. All right? So I know that 8 times 8 gives me 64. And if I do negative 8 times negative 8, that gives me a positive 64. But when I add negative 8 and negative 8, I get negative 16, which is what this is. So we'll have p minus 8 times p minus 8, which, since they're both p minus 8 and they're multiplied times each other, it's the same as p minus 8 squared. Okay? Here, same thing. And we notice that in front of the squared term, there's nothing there. So it's assumed to be 1. So that means our a value in our quadratic is 1. So we can just break it down. We know that's an a, we know that's an a, and because we have a b squared back here, we know it's going to be something b times something b. Okay? So again, we look at this 4. What factors of 4? Okay, so we have 1 times 4 and 2 times 2, basically. That will give us 4. Which ones of these can I add together and get negative 4? Well, if I make the 2's negative, right, negative 2 times negative 2 becomes a positive 4. And a negative 2 plus a negative 2 gives me a negative 4. There. So it's going to be a minus 2b times a minus 2b. Again, these are both exactly the same, and they're being multiplied together. That means it's a minus 2b squared. Okay? Over here, it's written backwards, so I'm kind of the type that likes to have it written the correct way. So y squared minus 11y plus 18. If you rewrite it, just make sure that you put the correct sign with each letter, okay? So if this was a negative 11, make sure it was, oh, that should be positive. Make sure you put the positive, the right sign with the right letter or right number. Okay, so we've got y and we got y, right? And then our factors of 18 that multiplied together give me 18, but are added together give me 11. First one that comes to mind is 9 and 2. 9 times 2 is 18, but 9 plus 2 is 11. So we would have y plus 9 and y plus 2. And that's it. That's all they need. We just want to know what these two factors are. Okay? So those aren't too bad because that's, again, when your a is 1. Now these next three, you have big numbers in front of the squared number, squared variable. And so what you have to do there is called the AC method. And basically you take a, which is 18, and you multiply it times c, which is negative 5. So 18 times negative 5 is a negative 90. So I need to know the two factors of negative 90 that when added together give me a positive 9. And that would be 15 and times a negative 6. Okay? All right, so we have positive 15 and negative 6. Multiplied together give you negative 90. Added together give you a positive 9. So when we get that on these, we're going to take these two numbers and replace the 9y in this equation. So we're going to leave the 18x squared there. Okay, so it stays y squared. But instead of 9y, we're going to split it up to 15y and negative 6y. Okay, and then plus 5. Okay, so now we separate these two and those two. So I look at these two terms here and I think, what can I factor out of those? Well, they both are factors of, or multiples of 3, so I can factor a 3 out, and they both have a y, so I can factor a y out. That would leave 6y plus 5 here, and then this is already 6y plus 5, and then, but it's a negative 6, and that's a negative 5. I'm sorry. I drew a circle around that looked like a plus. That's a minus 5. So I need to pull out a negative 1 so that I would have 6y plus 5 just like this. And when I do, 6y plus 5. So now I can take this 3y and this 1 and put them together. 3y minus 1 and 6y plus 5 here. Okay? And so those are your factors for this guy. All right, this one is a little bit more complicated because the numbers are bigger. But 25 times 28 is a negative, it's negative 25, is a negative 700, which you're thinking, oh my gosh, that's terrible. But when you look at this number right here, because it's a positive 60, it's not so bad. So I can multiply this by 70 and a negative 10. 70 times negative 10 gives me a negative 700, but added together give me a positive 60. So that wasn't so bad after all. All right, but I rewrite this equation, 28p squared, and then plus 70p minus 10p minus 25. Okay, and we put these together, and we put these together. And I can factor out a 14p out of this, 14p, and that leaves 2p plus 5. Yep, 2p plus 5. And here I can factor out a negative 5, and that also leaves me 2p plus 5. So, because these are both the same, I can put the 14 and the negative 5 in its own parentheses, and then 2p plus 5 in the other. And again, those are your two factors. So if I were to multiply these together, this times this, this times this, this times this, this times this, I would get that number right there, that equation right there. Okay? All right, on this one. So this one, we could actually factor a 2 out of this because each one of these are multiples of 2. So if I pull a 2 out of here, that would leave me 2x squared plus 13x minus 24. Okay? And then I can take 2 times negative 24, and that gives me negative 48. And the factors of negative 48 that add together to make 13 would be 16 and 3, I think. Yep, positive 16 and a negative 3. Added together, give you a positive 13. Okay, so our 2 stays out here, and this becomes 2x squared. Instead of 13, it's going to be 16x minus 3x, and then minus 24. Okay? All right, so then I put this together with this and this together with this. I can take a 2x out of here, and that leaves me with x plus 8. And over here, I can take a negative 3 out, and that leaves me x plus 8. So 2x minus 3, we have our original 2 down here. We got to bring down 2, and then 2x minus 3, and x plus 8. So all of that is your answer. All right, these they want you to solve, meaning they want you to actually find out what the values of x have to be. In order to do that, you break it down into their factors and then set each factor equal to 0 because it's saying that this quadratic is equal to 0. Meaning, if I can break it down into the factors like I did up here, right, and I set each one of the factors equal to 0, I can find out what x has to be. Okay, so I factor this, x, and x, and then I've got negative 72 here, so what numbers times each other give me negative 72, but when added give me negative 1. And that's a negative 9 and a positive 8. Multiplied together, negative 72. Added, negative 1. So negative 9 goes here, and a positive 8 goes here. We set it equal to 0. So now if I can get this, what's in this set of parentheses to equal 0, 0 times whatever I get here would equal 0. And if I can get this, or if I can get this to equal 0, no matter what's in here, this times 0 is still going to give me 0. So I set each one of those equal to 0. So x minus 9 equals 0, and x plus 8 equals 0. So I add 9 to both sides, and I get x is 9. And I subtract 8 from both sides over here, and I get x is negative 8. So you get two answers. So x can be positive 9, or it can be negative 8. Okay? On this one, oh, sorry. Trying to, here we go. On this one, I need to move this negative 8 over here so that I have it in the correct order, and I set it equal to 0. So if I subtract 8 from 8x from both sides, I end up with 3x squared minus 8x plus 5 equals 0. All right? And then if I go to factor, I take 3 times 5 and I get 15. So the factors of 15 that add together to give me negative 8 would be a negative 5 and a negative 3. Okay? So 3x squared minus 5x minus 3x plus 5 equals 0. Okay? So I can factor, looks like an x out of here. All right? And that leaves me 3x minus 5. And over here I have negative 3x plus 5. So if I factor a negative 1 out, I would get 3x minus 5. So now I can put this x and this negative 1 together, and we get x minus 1 and 3x minus 5 equals 0. So I can set x minus 1 equal to 0. All right, and that is adding 1 to both sides. X is 1. So that's one answer. And then I can set 3x minus 5 equal to 0. Add 5 to both sides, and I get 3x equals 5. Divide both sides by 3, and x is 5/3. Okay, so those, again, you've got two answers there. Okay, on this one. This one is the difference of squares. You have a perfect square in the front, subtracting a perfect square right there. So I can write 2y, which is the square root of that, minus 5, which is the square root of 25, and multiply it times 2y plus 5. So it's just the opposite of that. Okay? And that equals 0. And that's factored down. All right, so then I take 2y minus 5 equals 0, and 2y plus 5 equals 0. So if I add 5 to both sides and divide by 2, I would get y is 5/2. Over here, I subtract 5 and divide by 2, I would get y. Oops, sorry. Y is negative 5/2. All right, so again, two answers. All right. This one, if you look at all of these are all divisible by 2. So I'm going to factor a 2 out of here. All right, and if I do that, that leaves me with 3y squared plus 7y minus 6 equals 0. All right, and then when I go to factor, 3 times negative 6 is a negative 18. So the factors of negative 18 that add together to make positive 7 would be positive 9 and negative 2, it looks like. Yep, positive 9, negative 2. So 3y squared plus 9y minus 2y minus 6 equals 0. Okay? And again, you're going to put these two, front two together and the back two together. All right? So I can factor a 3y out of this. So I have 3y. That leaves me with a y plus 3. And then I can factor a negative 2 out of here. And that leaves me, if I divide this by negative 2, it leaves me with a y minus 3. Or y plus 3, sorry. Plus, it's minus 2. Okay? So I put the 3y in the front here with the negative 2 in its own set of parentheses. So 3y minus 2 and y plus 3 equals 0. Sorry, I forgot to put that. Plus we've got our 2 out here in front, which that that you can't equal to 0, so that actually just, you kind of ignore it, because if I can get either one of these to equal 0, this 2 is not going to matter anyway, because 2 times 0 is 0, or 2 times this 0 is 0. So I have to set 3y minus 2 equal to 0 and y plus 3 equal to 0. So we're going to come over here where we have some room, and we've got 3y minus 2 equals 0. So I add 2 to both sides, gives me 3y equals 2, and then I divide by 3, so y is going to be, sorry, that's ugly y, 2/3. All right, and then this one, I have y plus 3. Y plus 3 equals 0, so I subtract 3 from both sides, so y would be negative 3. So we'll have negative 3, and we have 2/3. Okay? All right, 25 is another difference of squares like this one over here was, right? It's going to be the same type of thing, because 25 is a perfect square, x is a perfect square, and 36 is a perfect square. So the square root of 25 is 5, square root of x is x, square root of 36 is 6. So we minus 1, and then we plus 1. 5x plus 6. There we go, equals 0. So then we set 5x minus 6 equal to 0 and 5x plus 6 equal to 0. So 5x minus 6 equals 0. Add 6 to both sides, and you get 5x equals 6. Divide by 5, and x is 6/5. Over here, 5x plus 6 equals 0. We subtract 6 from both sides. You get 5x equals negative 6. Divide by 5, and you get x is negative 6/5. So a negative 6/5 and a positive 6/5. 22, we need to bring that negative 1 over to the left, and we would have 12d squared minus 8d plus 1 equals 0. So 12 times 1 is 12, obviously. So the factors of 12 that when you add them together give you negative 8 would be a negative 6 and a negative 2. Negative 6 times negative 2 is a positive 12. Negative 6 plus negative 2 is a negative 8. So, we rewrite this equation. 12d squared minus 6d minus 2d plus 1 equals 0. Again, we're going to put these together, We're going to factor a 6d out of this. Leaves us 2d minus 1. And then this is already d plus 1, negative d plus 1, so we factor a negative 1 out. And we end up with 2d minus 1 equals 0. All right, so 6d minus 1 and 2d minus 1 equals 0. All right, and we're going to set each one of those equal to 0. Because if we can get this to be 0, then your answer will be 0. If we can get 2d minus 1 to be 0, it'll all be 0. All right, so 6d minus 1 equals 0. Add 1 to both sides, and you get 6d equals 1. Divide by 6, and d is 1/6. Okay, over here, we get 2d minus 1 equals 0. Add 1 to both sides, and you get 2d equals 1. Divide by 2, and d equals 1/2. So you got 1/2, and you got 1/6.